Hello everyone, I am Omkar Jagdale from C Division and I am going to explain this VHDL code implements a 4 to 2 encoder which takes a 4-bit input and converts it into a 2-bit output. It also checks whether the input is valid or not. Here is a breakdown of this code. First is library. The code starts by importing some standard VHDL libraries. IEEE.st logic. This is used for standard logic operation. And second one is entity declaration. This defines the external interface of the encoder. Input 4-bit vector array of 4 bits, which is the input to the encoder. Output 2-bit vector representing the encoded output. Valid a single bit that indicates whether the input is valid for encoding. Then architecture. The architecture describes the internal behavior of the encoder. First is the process of block. This block is where the actual logic happens and it's triggered whenever the input changes. And second one is the default values. Before checking the input, it sets output to 00 and valid to 0. This ensures that there is a default output if no valid input is detected. And next one is the encoding logic. The code checks the input value and assigns the corresponding 2-bit encoded output. If the input is 0001 and output is 00, and valid is set to 1. If input is 0100, the output is 10 and valid is 1. If input is 1000, the output is 11 and valid is 1. If none of these conditions are met, the output remains 00 and valid stays 0, indicating an invalid input. So moving towards the summary, the input is a 4-bit vector where only one bit should be high at a time. The output is a 2-bit encoded value representing which bit of the input is high. And third one is the valid signal that tells whether the input is valid or not. So this is about the encoder, which is a 4 to 2 encoder, likely most correct, but you may want to make a few changes to improve its correctness and awareness standard. We can also replace the standard logic or and standard logic unsigned. So these libraries are non-standard instead of considering all of those. Thank you.